Before going for a deep dive in the Unreal Engine, let's talk about Megascans, because I don't think I can possibly talk about UE4 without mentioning Quixel. At this point, I think I used Megascans to some degree on every project, both work-related and personal. So of course the example that I made for this tutorial is no exception. The way I usually go about scouting for Megascans starts with analyzing the reference and trying to boil it down to minimal amount of materials and assets that can help me replicate that reference in CG. With the boat, for example, I knew that I would need some heavily rusted metal and wood planks for the deck. The lighthouse with the lightkeeper's house would need some painted wood and painted brick, as well as some kind of a roof material. I also found some props that can work well with the theme, like this bucket and barrel, or this rusted chain. It's also a good idea to grab some leakage decals that can help break up any noticeable tiling in your materials. Since my boat and the lighthouse were mostly covered, I looked for some rocks, something that can help me build that Eddystone-like rocky island. It's always a good idea to stick to one biome so that the assets you pick look coherent together, and in my case, I decided to stick with Icelandic biome. I usually look for scans that look generic enough so that I can reuse them a lot. Also, I like to cover a good range of scale, from larger assets to medium and small, and filtering by size can help a lot with finding right size and stepping down from large to medium and so on. Most of the assets were downloaded with 2K LOD0 preset. It's very easy to re-download and re-export higher resolution mesh and textures if you need to, but I think for a start LOD0 and 2K will work just fine. I'm honestly always amazed by the amount and variety of assets that Megascans library holds, and I was able to find almost everything I need except for a few things. For example, this metal scan was great, but white paint didn't really work with what I had in my reference. I wanted my boat hull to be black with green accent color. Fortunately, that was a very easy problem to solve using Quixel's mixer. So in the mixer, I started with the base texture that I liked and added a solid layer. Changed its color to green and made sure that it's set to masked by opacity and is wrapping to the underlying layer. That already looks like painted metal, except that now we lost all that awesome looking rust. So to fix that, I added a mask stack and the map component, where I chose my base metal and set the mask to use albedo. Basically what it does is it takes albedo of the base metal and uses it as a mask. This will work well because that albedo already has a good contrast between white paint and the rust. Of course, I had to play around with the range to isolate the rust even more, and that gave me exactly what I was looking for. So I duplicated that solid and changed its color to black. Now I got two materials, green and black, and I exported both of these new materials. Now if I go back to Bridge, I can find them under Mixer tab. From here, I could easily export them into Unreal the same way we export everything else. I think at this point, with all these custom assets that I made and everything we got from Megascans, it's a good time to jump into UE4 and start working on the look dev and assembling everything together. A quick disclaimer though, you will benefit the most from this tutorial if you have at least basic understanding of Unreal and its UI. Epic has official tutorials on their websites and on YouTube. And I also have an intro to Unreal tutorial that I made specifically for concept art. So there are a lot of ways to learn the basics. That's why I wanted to keep this tutorial at an intermediate level. For this example, I was running version 4.25 with the ray tracing enabled, of course, and starter content enabled as well. There are a few custom settings that I usually use under project settings. First would be using precision normals. And you can easily find all this stuff just by typing its name in the search. Next, I would usually disable static lighting since we will be using ray tracing for all of our lighting, both direct and indirect. Lastly, I disable texture streaming so that I can have sharp textures at all time. Also because using two 2080 Ti's with NVLink allows for memory sharing, which gives me a ridiculous 22 gigabytes of VRAM. Considering all that, I don't think streaming will ever be an issue. And now we can start by looking at how I set up lighting. It's something that you generally want to do before touching your materials or anything else. By default, this template had a sun and a sky system, which is great, but I wanted a much softer lighting, so I had to use an HDRI backdrop instead, which you can find under Lights tab. An HDRI backdrop is pretty much a skylight and a sky dome combined together by the blueprint. It comes with an HDR map by default, which I swapped with the Sunset HDR, which I imported earlier. Importing an HDR is the same as importing anything else in the engine and is done by clicking on the import button in the content browser. Also, you want to double click on that HDR once you imported it and make sure it's set to no mipmaps under level of details. Otherwise, your skybox will look blurry and you won't get full resolution of that map. Another quick thing you want to do with the HDRI backdrop is set its size so that it covers your entire scene. In my case, it was 1000 units, which I believe is a kilometer. Now with the HDRI selected, you can use Gizmo to rotate the sky, and that will also update the light direction. The fact that ray tracing allows us to get this quality of lighting and reflection in real time still amazes me every time I look at it. And of course, at any time you can change the map, and that will update skybox and the lighting, which is pretty mind-blowing because all of this is running in real time. Don't forget that you can always manually adjust exposure for the viewport instead of having it auto-expose. This is more of a temporary solution for while you're working. Your final exposure adjustments should always be done through the camera or post-processing. Now is actually a good time to quickly jump into post-processing and adjust few ray tracing settings. One easy way to clean up your post-processing to only what you need is to use the search bar. In this case, I will type ray tracing, or you can just simply type ray, and you will get all the available ray tracing settings. Right away, I will enable GI and use brute force and change maximum roughness of reflection to 1, which means that every reflective surface will be ray traced. Rest of the settings can stay as is for now. We will increase them once it's time to do final capture. You can use Ctrl H to show frame rate stats, and I usually like to keep them on. That way I can keep an eye on performance dips and make sure that I'm not pushing the engine too much. Although I'm not going to lie that with all the latest updates and the latest video cards, it's getting really hard to get to a point where FPS is so low that you can't actually work. And you will actually see it for yourself once I start adding more objects into this scene and pushing these video cards a lot more. Also, if you're wondering where I got this color calibrator, you can search for it in the engine content folder in the content browser. You just need to look for a color calibrator. And at this point, it's a good idea to start importing all these custom assets that I made. In the import settings, I made sure that it does not generate light maps and combine meshes is turned off. Importing the ocean plane was a little bit different just because it's not an FBX file. So under Alembic import options, I chose geometry cache under import type, and I made sure that it covers my entire animation range, which was 200 frames. I did some tests with different compression precisions, and it didn't look that much different, so I kept all these values at default. And last step would be scrolling down and selecting a conversion preset. For me, it's 3ds Max, and that's also what you should be choosing if you use Blender. Keep in mind that importing a large Alembic file can take a few minutes, of course. Now, once you get everything imported, don't forget to save all of it, and it's a good idea to organize your folders and meshes. From this point, we can actually work on the look dev, and I will start with the boat. I will drop it in the scene, and it comes in multiple parts since we told Unreal not to merge meshes. Next step is pretty straightforward. I would navigate to the folder with all the Megascan surfaces and start dropping them directly on the model. If you set up your material breakdown correctly, it should apply materials to certain parts of the model and not the entire model instead. Now I can actually show you why I wanted to have UVs on the boat hull to run straight at the top. Because it's an actual scan, the seam looks very nice and realistic. Of course, I wanted to incorporate it in the model to realistically break up the separation between painted metal and the rest of the hull. This seam in the texture is straight, so my UVs had to match that. Adjusting your UVs to certain features of the model can often make it look like a completely custom texture, and as you can see in this case, it fits beautifully. Once I pick which materials I'm going to use, I would create an instance and start messing with tiling and UVs offset to further adjust the look. I'm mostly looking at the things like direction and position of the rust and the overall scale of details. Basic things like this will add a lot of realism, and in cases where you need to fine-tune texture positions even more, you can use UV transform tool, which you can find under modeling, UVs and normals. Selecting a face will let you move, rotate and scale UV islands. When it's done, all you need to do is click accept. You can also use auto unwrap and different types of projections in case you have a model that has no UVs at all. And when you're done, you can go back to select mode. Following the same principle, I applied materials and adjusted tiling for the rest of the boat, as well as the lighthouse and the house. It's a very quick and fun way to texture. And if you are creative with matching features of your models with features in the textures, you can get a very convincing looking result, even with generic tiling textures. There are only few things like ocean and glass shaders that I couldn't import from Megascans, so I had to make my own versions. Now we can start by taking a look at how I set up glass shader. It's very simple and it gives nice amount of control. I will start by creating a new material. Next, you can give it some logical name and make sure that you change its blend mode to translucent. And lighting model to subsurface forward. Also, if you scroll all the way down, you want to change refraction mode to pixel normal offset. Now we can start working on the nodes. First, you will need a free vector that will drive color of the glass. Make sure you convert it to a parameter and give it a name like glass color or color. You want to do that so you can have control over this parameter without going in the shader again. Next, you will need a constant, which you want to convert to a parameter as well and name it specular. You can duplicate it now and rename it to roughness. Your default values should be 0 for roughness and 1 for specular so that it's nice and reflective. Now we can work on opacity. You'll need a texture sample if you want to have a dirt mask in your opacity, and you will need to convert it to a parameter as well in case you want to change that texture later. Now we want to multiply it by another constant parameter, which will drive intensity of the opacity. And we're almost done. I will create another texture sample for normal map and one more constant for refraction, which will control the intensity of refraction. Last step would be going into default Megascans shader and stealing its UV controls. You can find default shader under MS presets folder. All you need to do is select that entire block and copy it. Now you can paste it into your glass shader and connect it to a normal map and opacity map UV input. I can save this shader and make an instance now. This way I can have access to all these parameters that we just set up. Now by controlling opacity and refraction, you can create a different looking glass. As for these maps, opacity has a surface breakup map from Megascans. You can find tons of different breakup maps under surface imperfection section, and the raindrop normals I got from textures.com. Now that I got glass set up, I was able to finalize the boat and the lighthouse since both of them use that shader for windows. Now let's take a look at how I did that ocean shader, and after that we can move to actual world building. After you drop in your Alembic Geo in the scene, you can quickly test the animation by using simulation mode. And I usually just use Alt-S hotkey because it's much faster. I think this looks pretty convincing. We got some foam going on and it's only happening at the peaks of the waves. And there is a secondary level of details which I'm getting through the normal map. And of course, we can have control over a lot of its parameters to quickly change the look of it. What's great is that you can even change the scale of the waves and playback speed. And that alone can create a completely different feel and a lot of different types of bodies of water. Let's look at the actual shader now. I promise you, it looks a lot more complicated than it really is. The base of that shader is default. There is no translucency or any extra settings that need to be enabled. It essentially has three inputs: color and foam, and roughness and normal. Let's look at the foam first. It's a texture map, which is multiplied by a constant, which drives the intensity of the foam. And it also has a separate UV control here. And in that control, I removed everything but tiling and named it foam. So this way I know what this tiling is driving. So the foam texture is being lerped with the water color, which is a simple color vector. And all of that is masked by a vertex normal. This node lets you mask certain parts of your model based on their world position. In this case, color represents which axis is being isolated, and blue is Z. You can see that in the little gizmo, so green is Y and the red is X. And the rest of this madness basically inverts the selection and gives me control over blending intensity. So basically this is our mask, and then the color of the ocean and the foam. I'm also taking output from the foam and multiplying it by a constant that will drive roughness intensity. That lets me remove some of the glass from the parts of the water that has a lot of foam, since foam is not really that shiny. The normal map is pretty standard. I have a constant that controls its intensity, and it has its own set of UV controls that have nothing but tiling again. And that is pretty much it. I promised you it was actually very simple. And you can just copy this setup and play around with nodes and all the settings. You could also make it translucent the same way we did the glass, but for my example, I wouldn't gain anything by adding translucency. You simply wouldn't see it because we're dealing with the deep water. The foam map is just a tiling foam from cgtextures.com, and I grabbed a few different ones to see which one works best. And as you can see, you can easily change them on the fly, and that changes how the ocean feels as well. Now, these character guys ended up looking very stiff after Mixamo, so I didn't bother giving them any fancy shaders. I just wanted solid colors for clothing and skin so that I can paint on top and give it some life in Photoshop. And that gave me pretty much everything I needed to start building a little scene. Before actually going and building anything, I like to lay out all the available assets. It's like dumping all your Legos on a table to get a better idea of what parts you have. So all my Megascans and all the custom stuff I made is here. I can quickly judge its scale relation to each other and also see what kind of silhouettes I have available. All of that helps me get my decision making much faster, since that way I know by heart what exactly I'm working with. There is this one custom decal which I wanted to show you. It's basically a copy of this leakage decal, except that it only affects roughness, so that I can get really cool looking water streaks effect on the boat deck. I made it by duplicating default Megascans decal shader and changing its decal blend modes to debuffer, translucent, normal, and roughness. And I really hope that guys from Quixel know how much I love them and forgive me for messing with their shaders all the time. Alright, let's do a quick recap before starting the time-lapse. I got all these assets in the scene in a sort of a playground fashion. It's lit by a soft HDRI, and I do have an exponential fog in the scene with volumetric fog enabled, and directional in scattering is set to black so that it doesn't cast any extra color in the fog apart from what that fog gets from the lighting. As I will start building the scene, I will increase the fog density and the height fall off as well, but these are the only two settings that I really end up using. And of course I have a post-processing volume, and I have ray tracing enabled for everything but refraction, and I will talk more about final post-processing setting once we finish the scene, of course. And I think at this point, with the power of editing, I will move to time-lapse. So I'm grabbing assets directly from my little playground area, and I'm duplicating them, of course. At the same time, I'm looking at the reference on the second monitor, and I'm trying to figure out the logic and the feel of what I'm seeing, instead of copying it directly. This is also a good example of why you don't need a lot of unique assets. One great and generic looking rock can be reused until you get an entire rock formation. You just need to rotate and change its scale. The key is to look for noticeable repetition and try to hide that as much as possible. Analyzing your reference is especially important for replicating nature. Understanding the logic and context can help a lot. So these rocks, for example, are being crushed by the waves constantly. So there will be some directionality to how they break and how this island is formed. This stuff doesn't require any deep knowledge in geology. A lot of it can be done from observation and simply looking and understanding your reference. So with all that in mind, I'm adding more flat areas and adding smaller crushed rocks on the outside of the island because it will be the most affected by the force of waves. I'm also extending the overall footprint so I have enough space for the house. Also, apart from making it look believable and logical, I'm looking at the composition of the shapes, since we're making a concept art and not a scientific illustration. That's why you can see that I'm trying to extend the island horizontally and adding more sharp-looking rocks. The visual language of this place should read tension and danger. This is one of the examples where the shapes are not ideal, and I'm pushing these scans a lot more than I should, which is fine since I know that I will fix a lot of that during paint over. And if this was meant to be a cinematic or a game level, I would have to do some custom assets, of course, but with concept art, I can get away with a lot less polish. I'm just trying out different angles and different scale. This is where UE4 shines the most, and this is where this pipeline shines the most. It has a speed and flexibility that lets you quickly adjust to change and try many different variations along the way. Now I'm finally placing the house, and of course I realized that there's still not enough space for it, so I'll have to extend the rocks a little bit more. And every time you see that I paused, I'm basically looking at it and trying to figure out what's my next move should be. It's very important to take these little breaks and make sure that you're not spending your time on something that's not adding any value. I'm also adding these wood blocks, which makes it look like abandoned infrastructure, and stuff like this is great for scale, and I'm also using it for storytelling. I think the narrative I had in my head is that the lightkeeper went mad from the isolation and turned off the lighthouse. So there's basically a ship graveyard all around him, and the boats I'm about to place are actually on their way to crash into these rocks, while the lightkeeper is just doing his regular routine and watching that happen. You know, not the H.P. Lovecraft level of storytelling, of course, but it's fun to make these little narratives, plus they help to keep the logic of your art somewhat consistent. Once I got the lighthouse area to a certain level, I decided to move on, but before that I added some more fog and played around with the idea of having it black and white. This is actually something that I'm still going to do for the cinematic shots, but when it comes to panorama, I realized that no matter how much I want it to be black and white, it works a lot better in color, so I let myself to deviate a bit from the movie reference. Now I'm placing the boats, and the way I'm keeping it as a single asset is by using Ctrl-G to group all the selected meshes. And when I placed the boats, I started thinking of potential ways I can capture this, and I always see this as doing photography and thinking where I would place the camera. Now I'm rotating the ocean and trying to get a nicer position of the waves, and also extending it by duplicating the ocean planes. And of course I'm adding the actual rocks that the boats will be crashing into, and removing the light beam to keep it consistent with the narrative. Otherwise, why would these boats crash if the lighthouse was functional? At this point I had an idea which boat will be the one I will be capturing from, so it becomes the center of the world in a sense, and it should get the most love and attention to detail since it's the closest to the camera. So I started by placing decals to add second layer of detail and surface variation. I also adjusted roughness of most of the materials so that they look a bit more reflective and wet at the same time. And when shaders were done, I started working on adding more props. These pipes and valves might be a bit too forced now that I look at it. I'll probably tone it down if I were to go back and fix this. So I'm dressing it more with the props from Megascans, adding a lot more smaller scale objects. The progression usually goes in layers. You start with the larger shapes and you go down to medium and smaller scale objects as you get closer to finalizing your scene. The beauty of Megascans is that I didn't have to spend time on making any of these, because making high quality props can take a lot of time, and that's the time that I can spend painting multiple versions of this, for example. Now, placing these rope decals, I wish I had geometry there, but you gotta work with what you have, and in this case I had decals only. And I'm adding a bit more decals. Stuff like this works great to break up flat areas. Now adding leakage, stuff like this works great for breaking up repetition in textures. You just need to be careful not to go overboard, and also placing them where they would make sense from a logical point of view. Looking at the reference can help once again with figuring out what's logical and what's not in this case. And here, as you can see, I'm using UV adjustments to get a better seam placement on that door. And duplicating more props, I'm just spreading them nicely all around the boat. I finally started to place characters, and I'm giving this guy a lantern with a point light. I'm using light temperature to make it warmer and offset a bit of that cold and monochromatic lighting I have in the scene right now. As you can see, I added more lights on the boats to get some splashes of warmth. All of them are point lights with the high contribution to the volumetric fog. And I knew that I want to make multiple captures to show you guys how scalable this workflow is. So I moved away from the boat and started dressing the lighthouse area a bit more so that I can have a capture from the lightkeeper's perspective looking at the boats as they're about to crash. This position will also work great to show the ship graveyard all around the lighthouse. So I'm duplicating the boats and moving them around. Because the boats were modular, I can remove and duplicate some of its parts, like the pipes, for example. That can add some more variation and make it look like they are different boats and not just clones. And as you can see, I'm scaling it and, changing proportions again to add more variation. And I didn't want it to be in your face, so I pushed it back into the fog. So I'm adding some fake lights, and one of the things that I actually tend to forget is that you can have multiple viewports in Unreal. And in this case, I'm using a top-down unlit mode in the second viewport to get that light position where I need it to be. Getting some dry grass and dead bushes from Megascans, and I'm using foliage tool to place them. And I'm also using a single placement mode. That way I can have more control where it's being placed. And of course, foliage tool is randomizing its size and picking different mesh every time I place it. And a little bit more props, again, to help tell a story a little bit better, but also to add a bit more visual variation and scale variation. Now this rock here was a great example of how you can up-res stuff quickly when you need extra details. I was planning to capture around it, and 2K texture was definitely not enough considering how much I scaled it. All I had to do is go back to Megascans and download an 8K version and export it. Once it was in the engine, I replaced that 2K with the freshly imported 8K, and that was all there is to it. And now I'm actually doing the capture, but don't worry about that. I will walk you through Ansel and how it works in the next chapter. And this actually concludes the time-lapse section and the world building as well.